Yes, I welcome you all for another presentation on electromagnetic field theory. Electromagnetic field theory. If you recall, in our last presentations, we have seen certain brief information about electrostatics as well as magnetostatics. Right, again just I want to give you little bit more brief information, and subsequently we can go for the next information. So in electromagnetic field strength or field theory, as I have explained, that it is the combination of electrostatics, right? It is the combination of electrostatics, nothing but it describes about the electric fields. Electrostatics, nothing but it describes about electric fields, right? It describes about electric fields, and it has again magnetic is nothing but magnetostatics. Magnetostatics. This describes about magnetic fields, right? Magnetic fields. So it is the combination of these two. So electromagnetic field theory is nothing but electric field as well as magnetic field. These two are there in this particular subject, right? So electrostatic is nothing but electric fields, as well as magnetostatics describes about magnetic field, right? So to this further extension, in this electric field or electrostatics, otherwise this electrostatics describes about for stationary point charges. Stationary point charges, right? So for stationary point charges, the electrostatic field theory is applicable, right? Otherwise the electrostatics is describes about the stationary point charges. Okay, that is very important to remember. Stationary point charges. Electrostatic is applicable for stationary point charges, whereas magnetostatics. So this magnetostatics is applicable for steady currents, right? It is applicable for steady currents. Steady currents. A constant current, otherwise you can say a constant current. Steady is nothing but a constant current. So for this analysis of steady currents, the magnetostatics will be applicable. Whereas the third category, for time varying currents, for time varying, for time varying currents, for time varying currents, so the electromagnetic waves or electromagnetic field theory is applicable. Electromagnetic waves or electromagnetic field theory is applicable, right? Therefore electrostatics and then magnetostatics, and the third is the combination of these two, electromagnetostatics, right? So as I have discussed now, the electrostatics describes about the stationary point charges only. Similarly, the second one is the magnetostatics. The second classification is magnetostatics. It is useful or it is applicable for the steady currents. The steady currents, and the combination of these two, electro and magnetostatics. Okay, electromagnetic waves, otherwise that is applicable for time varying currents. Time varying currents. These are the very three classification that one should remember. If you note down these three, that itself covers the total subject of your electromagnetic field theory. This is what electromagnetic field theory is nothing but. So in overall, we can say that we will discuss about the stationary point charges and then steady currents, and then the time varying currents also, the behavior of the stationary point charges we will cover, And similarly, the behavior of steady currents and then the behavior of time varying currents will be studied under this electromagnetic field theory. That is what another important information that I want to cover in today's presentation. And now if you recall our previous presentation, there we have seen the very beginning and foremost means in electrostatics. Let us consider, I think we have considered the electrostatic first, and we have seen one important definition also there, Coulomb's law we have seen. I think you are all okay following that. So in electrostatics, why? Because our electrofield theory or electromagnetic field theory starts with electrostatics. It starts with electrostatics, right? Electrostatics. So in this electrostatics, the very beginning point is nothing but your Coulomb's law. Okay. So the very important is Coulomb's law. This we have seen in the last presentation. Let us recall, and if you need, please go through our previous presentation of EMTL. Under EMTL subject, I already covered that. It is there, it is available in our presentations in our YouTube channel. Coulomb's law. What is Coulomb's law? In brief, I can write that Coulomb's law is nothing but it describes about the Coulomb force, and that gives us F is equal to Q1 into Q2 by 4 pi epsilon naught into d square. This is what we have seen. Newtons. This is what the Coulomb's law or Coulomb force. This force is called as Coulomb force, where Q1, Q2 are the point charges, where Q1 and Q2, these two are called as point charges. Those are called as point charges. Why it is called point charges? Means that they will be placed at certain point, stationary point. They will not move here and there unless we place them, right? If you put somewhere, they will be constant. That is why they are called stationary charges. As I have just now explained, the electrostatic is applicable for stationary point charges. Stationary means a constant. They will not move. That is what. Therefore, Q1, Q2 are point charges, and your epsilon naught. What is epsilon naught? It is free space permittivity. It is free space. Free space permittivity. That we have to, and it has a constant value. It is something 8.854 10 power minus 12 Faradays per meter. You are not required to by heart this value, because while giving in your university examinations or otherwise even in technical competitive examinations like GATE examination or UPS examinations also, constant values will be provided in the question paper itself. You are not required to remember these things, but however, I suggest you that please remember, nothing wrong in that, because throughout the subject we will come across these constant. Therefore, by practicing the problems and while solving the concept, while preparing for the concepts, obviously you will come across these constants repeatedly throughout this subject, especially in electrostatics. Because in magnetostatics it will not come. Epsilon naught is applicable in your electrostatics only. This is applicable for electrostatic field only. But magnetostatic we will get permeability, that is mu. In magnetostatic, there I will explain, mu will come instead of E, epsilon. Okay. In general, if you see that actually the permittivity is equal to, it is the product of epsilon naught and then epsilon r, really speaking. This is the definition of permittivity, sometimes called as dielectric constant. Sometimes the permittivity is also called as this epsilon is called as, okay, dielectric constant, right? This is called as dielectric constant. This is also called as dielectric constant. So because wherever the experiment is to be conducted, there we will consider the atmosphere or the whether you are conducting in some particular medium, right, or in free space, right, the area where you are conducting that particular experiment or whatever it is. Therefore, we have to consider the constant, dielectric constant. So that the medium will have certain value of it. Okay, say for example, if you consider in free space, if you consider in free space means in open air, if you do certain experiment, then it has certain constant that is called as E suffix r, epsilon suffix r, it is called as relative permittivity. What is epsilon suffix r is nothing but r stands for relative, okay, relative permittivity, that is called as relative permittivity. For free space, your epsilon or r is equal to 1, epsilon suffix r is equal to 1. For free space, epsilon suffix r value is 1 actually. Epsilon naught is, however, it is a constant, that value is this one, 8.854 into 10 power minus 12 Faradays per meter, right? That we have to remember, right? So these are what so in our last presentation we have seen the definition of that Coulomb's force, right? I think we have seen that much only. In today's presentation, let us see a little bit extension of this. The next important after this Coulomb force, the next important thing is electric field strength. The very important parameter that we need to consider after Coulomb force is that electric field strength. The next very important thing, electric field strength. Electric field strength. Electric field strength are also called as electric field intensity. This is also called as electric field intensity or magnitude, you can say. Intensity or strength are nothing but, okay, that both are represented by the capital E only. Electric field strength or electric field intensity, both are denoted, both are same actually. These two terms can be used for this electric field strength or electric field intensity, that is denoted by E. So here it is simple mathematical expression only. There is nothing theory to by heart or to study actually or to read. So it is a mathematical expression only. So the electric field strength is mathematically given as electric field strength E is equal to Coulomb's force per unit charge. It is measured in volts per meter actually. This is the simple expression that you need to remember, and it is very much required. It is very much useful while in your competitive examinations. F by Q. Therefore, once if you know the Coulomb force, this force is nothing but Coulomb force. What we have seen in last presentation or just now I have given the expression. Okay, if you know the Coulomb force, that force is divided by the charge Q, F by Q, that gives the value of E. This E is nothing but electric field strength or electric field intensity. Okay, for defining this particular definition, that Coulomb force, how that can be given as, actually for definition purpose we have seen Q1 and Q2. For the definition of the Coulomb force, we have considered 2 point charges Q1 and Q2, whereas for considering the electric field strength, E is equal to, this is nothing but Coulomb force per point charge Q. In this case, for defining electric field intensity, this particular F is nothing but, actually F is nothing but Q1 into Q2, what we have seen, this one, no, 4 pi epsilon naught into d square, clear? This is what force, what we have seen. This is what force by this Q. This is equal to, assume that for defining electric field intensity, assume that Q1 and Q2 is equal to Q itself. Assume that Q1 and then Q2 is equal to Q itself, right? So in this case, your Q1 is nothing but Q only. Again Q2 is nothing but Q only by 4 pi epsilon naught into d square. This by Q is nothing but, it will come here only. Then this Q, 1Q will be cancelled out. What we will have, you know, it is Q by 4 pi epsilon naught into d square. This is what electric field intensity formula. That's it. That's it. That's it. Q by 4 pi epsilon naught into d square, volts per meter in general. So it is measured in volts per meter. This is what another important definition that you should remember. electric field intensity is equal to the Coulomb force per charge Q. Therefore, this is what F by Q. So, where F is nothing but Coulomb force Q1, Q2. But for the purpose of defining E, I am considering Q1, Q2 as Q itself. Therefore, Q into Q by 4 pi epsilon naught in D square, this by Q comes automatically here. Therefore, both numerator denominator Q's will be cancelled out. You will get this, the remaining one. This is what electric field intensity. So, as far as this subject is concerned, what I suggest you that remember the formulas itself. Remember the formulas. That's it. If you remember the formula directly, the questions will be asked in competitive examinations based on the formulas itself, especially in GATE as well as UPS examinations or any state and then central level technical competitive examinations. They will be asked, especially based on this particular subject. They are formula based only. Therefore, if you remember the formula, the given quantities, if you substitute in the formula, you will get the direct answers. Therefore, that is what the second parameter. Therefore, the first parameter is Coulomb force and the second parameter is electric field intensity, and the third parameter is that electric flux density. Electric flux density. Electric flux density denoted by capital D. Denoted by capital T. This is what electric flux density. What is electric flux? What is the electric flux? Normally, we will assume that there will be a closed surface, closed area, let us say. We will assume that some closed surface actually. This is a closed area, you can call closed area. And also within this closed area, we will have certain charge actually. Certain charge will be placed, some stationary, wherever the stationary charges will be placed, we assume that that charge is enclosed by certain area. Okay, that charge is enclosed by certain area, that is why it is called as a closed area. This closed area is enclosed by certain charge, that is Q suffix En, means enclosed charge, or you can write in full form also, Q enclosed or Q E suffix En. Therefore, whenever some charge is enclosed by certain area, throughout this area some flux will flows. Remember that. Flux, electric flux will be flow throughout this closed area. That electric flux is denoted by psi. This is the symbol. Electric flux. This flux is called as electric flux, and that flux flows through this area basically. Okay. So, the total flux flows through this area is equal to the charge enclosed by that area. That is the relation between charge enclosed and then the total flux flows through this. Therefore, there is a relation between electric flux and the charge enclosed by that area. Means that the total flux flowing through this closed surface is equal to the total charge enclosed by that area. That is nothing but your Gauss law. That is called as Gauss law actually. Gauss law for electrostatics. Gauss law for electrostatics. It is nothing but the first. It is nothing but the first Maxwell's equations. Right? Soon we will see these equations. Maxwell's equations. This is the first form of Maxwell's equation or first Maxwell's equation. Okay, because as I already told in the first presentation of this under the CMTL subject, Maxwell's equations are the very highlight important core heart of this subject. Maxwell's equations. So in Maxwell's equations, basically you have four equations. One is the Gauss law of electric field or for electric field. Second one is the Gauss law for magnetic field, that is the second equation. And the third one is the Ampere's law, and the fourth one is the Faraday's law. Right? So Gauss law for electrostatic, Gauss law for magnetostatic, Ampere's law, and then Faraday's law. Collectively, these four will have their own mathematical expressions. So these expressions are collectively called as Maxwell's equations. Once if you know these four equations, you will become the expert of this subject. Then definitely I assure you that you will have full confidence over this subject actually. That's it. That's it. Therefore, try to understand in a I mean relaxed way and a very meaningful way of this. You will enjoy this subject actually, right? Therefore, electric flux. This is electric flux then. Electric flux, and from this so now from this electric flux, the flux density will be also evaluated. How? So let us say for example, in this closed area, I can make some partitions for this. I will make it in little bit partitions like that. If you make within a small pieces of this area, and then let us say for this portion, if I call D1, for this portion let us call D2. What is D? D is nothing but electric flux density. So for this area I will have electric flux density, and I am denoting it as D1. Similarly D2, D3, and then D4, and then D5. You will have different and so on and so forth up to Dn, let us say. Then if you take the overall D dot ds, this is nothing but your psi. That is the relation between electric flux and an electric flux density. Understood? Therefore, this is the closed area or closed surface, you can say. That is why this is called as, you know, what is the meaning of this? Integral over circle I am writing here. Means that we are evaluating the integration over this closed area. Means we are considering, we are evaluating by writing this integral over closed area is nothing but you are calculating the total electric flux available. Total electric flux is nothing but the electric flux density, right? So integral over d dot ds, why it is s? S is nothing but surface. Therefore d dot ds is nothing but electric flux. Therefore this is electric flux, d is the electric flux density. This is the another very important relation that to remember. Relation between electric flux and the electric flux density. Now I will write one more important relation. There is a very important relation between electric field intensity and then electric flux density, right? There is a relation between electric flux density. Electric flux density is nothing but density means capital D and E. And E, what is the electric field strength or electric field intensity? That is nothing but, you please remember that actually D, electric flux density, is directly proportional to E. Remember that. This is very important formula. This is the relation between. So the electric flux density is directly proportional to the electric field strength, right? If the electric field strength increases, automatically your flux density will also increases. And if the electric field strength is decreases, then your flux density will also decreases. This is a direct proportionality, direct relation. And if you remove this proportionality, then you will write one constant will be come into picture, that is D is equal to epsilon naught into E. This is the formula. D is equal to epsilon naught. This is very important relation. D is equal to epsilon naught E. In fact, these are both are very important, right? So D is equal to epsilon naught into E. What is epsilon naught? I already explained. This is free space permittivity. 8.854 into 10 power minus 12 Faradays per meter. E is the electric field strength. D is the electric flux density. I hope that I will stop at this moment, and we will see the extension of these in the subsequent presentations, right? I hope that you understood well, and please give your valuable suggestions and observations and comments, and if you need any other information also, you please comment on my in the comment box of our channel, that is electronics underscore by BSR, and do not forget to share these to your friends, okay? And this is quite very much a common subject for electronics background students as well as electric engineering, triple E and ECE, as well as electronics and instrumentation branch also. Okay, so exclusively for these three branches students, this subject will be very useful. And okay, therefore please share and also give your valuable feedbacks also, right? So with this I will finish up today's presentation, right? So thank you for watching the video. Have a good day.